Thank you very much. Thank you very much, and good afternoon. Um, this session pertains to the economics or economic aspect of water quality monitoring. I did put something together for the purpose, but I'm no economist. I'm not much involved in water quality monitoring per se. But there are some aspects of this discussion lead me to think about, of course, the Lake Biwa, Kyoto River, and also many of the issues that we're facing globally on what I call the lentic water environments, which I will describe in just a few minutes. Let's see. The question is, what is economics of water quality monitoring? I think you know better than myself or the professor Yazov, the economist. But let me try and see if I would be able to relate what I had to say or what I have in mind. But first of all, let's define water quality monitoring as something probably not so familiar with you in terms of use of the terms. But let's say the catalytic actions of acquisition, analysis, interpretation of data and information on the state of lentic-lotic, I'll come back to this lentic-lotic water systems, and for gradual, incremental, and long-term improvement of their basin governance. And I tried to do my best to make my point on this. The basin consists, lake basin, river basin, consists of a very complex combination of lentic-lotic waters. Lentic meaning standing bodies water, lotic, the moving water, but all in terms of ecosystems and human nature interactions in a historic context. Lentic water behaves rather uniquely. It has the integrating nature. The stresses come from all over the upstream, downstream, so on and so forth. Long retention time, longer than river waters. Complex response dynamics, we have been presented on lots of these complex response dynamics in chemistry, biology, physics taking place, particularly inside the lake in a way that is very difficult to predict. Everything affects everything else. And that has management implications. One, issues are mostly inseparable. Two, changes are gradual and mostly invisible. That's why monitoring is very important. Often unpredictable and uncontrollable. And these are very unique features of waters that has lentic properties, like lakes, reservoirs, wetlands, and so on. Let's look at the Biwa-Kyoto Basin. The Biwa-Kyoto Basin, you have already been introduced on this. We have 14 million people using water, but in terms of the uses of water, it's water being used, discharged, used and discharged and so on. And one calculation is the very downstream Kyoto River, the people use water that went through human bodies 4 times. So it's a very complex systems and has a very congested resource use. Of course, we have these many plans. We have many regulations, standards, and so on and so forth. And that constitute the very complex systems of management challenges and sustainable use. Water supplies in Shiga Prefecture, for example. 68% uses Lake Biwa water. But even downstream Kyoto and Osaka, mostly the river water, but they all come from Lake Biwa. So the use of water is all related to this particular form of water, lentic loaded complex, but mainly lentic water. But the waters are also used and discharged, wastewater discharged into the lake, in the case of Shiga Prefecture, into the rivers, particularly, for example, in the Osaka water supply is only a few kilometers downstream of the wastewater discharge of Kyoto. Okay, so it's very complexly interlinked. Shiga discharge, Kyoto source, Kyoto discharge, Osaka source. So the water quality monitoring roles and responsibility of Shiga Prefecture, particularly in terms of regulatory monitoring, effluent quality discharge into water courses leading to Lake Biwa, ambient monitoring of lake water quality. I'll touch on this later on. Kyoto, the same. Shiga, the Osaka, also has its own issues and challenges of having to deal with this very complex problem. A broader range of monitoring activities, drinking water quality surveillance, regulatory monitoring with the reference, ambient monitoring in flowing rivers into the Lake Biwa, and of course ecosystem status and trends, eutrophication, sediments, and so on and so forth, are very much a challenge for the Shiga Prefecture. Kyoto and Osaka are pretty much the same, except that they deal with the Yodo River, which also sourced from Lake Biwa. The ambient water quality monitoring of Lake Biwa, of course, spans a wide range of challenges, particularly in terms of eutrophication, COD, total nitrogen, total phosphorus. But at the same time, you have the trends that come out of this various activities. And there are some improvements. There have been some improvements over the past 35 years. Transparency, total phosphorus, and total nitrogen. But the COD is increasing. It's a quite puzzling situation. But in terms of the aquatic environment, habitat not restored to the level that is we want. And the major issues is really the habitat destruction, invasive species, and the global climate change impacts. Shiga Prefecture, in terms of payment, the drinking water surveillance, water users pay the tariffs to the municipal semi-autonomous enterprises. Regulatory monitoring efforts, the dischargers pay. Ambient monitoring in flowing rivers, that is basically being supported by the general public in terms of payment in way of tax to the government. Kyoto and Osaka, pretty much the same, except there are some transaction of monetary transaction between the downstream to the upstream because of the use of Lake Biwa water in a scheme called the Lake Biwa Comprehensive Development Project. But overall, we are talking about something, okay, yes, I have gone over this. So in terms of who pays how much to whom for monitoring, we have these situations. But some key determinants of the economics of water quality monitoring, let's see how we can envision that. One, conventional thought would be to address the cost of efficiency, numbers of parameters, and so on and so forth. That is a very conventional approach. But I think it's probably useful to look at the economics more in terms of regulatory monitoring activities are generally sequentially linked or the basins that we have already discussed. Ambient water quality monitoring is indispensable for lentic water systems like lakes and estuaries. So the linkages exist for upstream, downstream. withdrawal discharges cause-effect relationship through, though they may be only marginally coordinated. And that is a very challenging situation in terms of economics of water quality monitoring. In terms of ambient, we have already mentioned that the three features of lentic waters becoming a very challenging in terms of the span of economic investment, in terms of the research, knowing what is taking place, really for policy making is much to be learned about in terms of investment and the cost of monitoring. So the tentative observations would be the economics of water quality monitoring depends very much on policies, programs, institutions, and water use relationship of the system in question. It depends, it spans a wide range of governance challenges in water management, especially in relation to natural anthropogenic hydrological cycles, including the nature of source water, water use, discharges, and in the lentic basin environment. The third observation may be that the challenges facing lentic bodies of water of particular importance because of their behavioral features that we have already discussed. And lastly, let's look at a little bit more on this lentic water systems. The economics of monitoring is an important issue facing the governance improvement of the integrated lake basin management. What is integrated lake basin management? This is in relation to other global debates on water, like integrated water resources management, integrated river basins management, but those two concepts do not seem to have this very important features of lentic waters that has the long retention time, integrated nature, and complex response dynamics. Okay, so these are the 6 pillars of integrated lake basin management. Integrated basin management takes place on a long-term improvement of basin governance in which the measurement of the governance improvement has 3 indicators that we use. And the third one is pretty much what water quality improvement is about. So with all these things, the conclusion is economics of water quality monitoring may be defined as a societal imperative for addressing how efficiently and effectively we should generate, interpret, and use the catalytic information, the monitoring, to change for the better the governance of lentic basin systems. And that probably is a much broader conceptual framework that applies to a broad global challenge of water management, as well as to the linkages with the policy challenges, institutional challenges, and scientific and instrumental challenges of water quality monitoring. Thank you very much.
Thank you, Professor Nakamura. Now we have, okay, maybe 2 questions.
Thank you very much. Who sets and determines the water and the wastewater tariffs here in Japan?
The tariff, the water use tariff, basically is a semi-autonomous enterprises, semi-governmental enterprises that manages water, and the water production costs and so on and so forth are being sort of accounted for determining the water tariff system. So it varies from one place to another.
But when it comes into decision, are water users also involved in that setting?
Yes, water users are involved in several stages. Of course, there will be a lot of hearing. I think it's very difficult for the managers to come up with a water tariff and then impose on them. So from the very beginning, there is a pretty, sort of big debate as to how the water debate should be. And then expert group meeting. And then finally, we have the hearing of final decision making.
Thank you. It's very interesting concept. So if we look at this conceptual framework you have introduced, so the economics of monitoring goes actually beyond only the monitoring. It goes like throughout the whole cycle of water. So it is maybe more of the economics of the water resource management, or how This
is something that we have to ask, like people like Professor Yazanolov and other economists. I think this is one major area where I think that the water quality monitoring has a much broader profile, much broader challenges to face, because it may be a catalytic driver of the water challenge, which I don't think has not been the case, because the water monitoring and instrumentation is pretty much sort of confined with a very narrow disciplinary areas. And I think this crossing over all the way to the policies, institutions, and that's where the economics come in a very productive way. And that's the reason why I think this discussion of definition would be very useful.